Have you ever wondered what causes the tides? It's a question that has puzzled thinkers and scientists for centuries. We see the ebb and flow of the ocean every day, a constant reminder of the unseen forces at play. But what is it that makes the sea rise and fall in such a predictable pattern? Let's start with the basics. Tides are the rise and fall of sea levels caused by the combined effects of the gravitational forces exerted by the moon and the sun, and the rotation of the earth. It's a natural phenomenon that we observe on a daily basis, particularly if we live near the coast. But the reality is, most of us don't fully understand the mechanics behind it. The ocean is not a static body of water. It's a dynamic, living entity that responds to the push and pull of celestial bodies. When the gravitational pull of the moon and the sun reach out across the universe and tug at our planet, the sea reacts. The water bulges out in the direction of the moon, creating a high tide. On the opposite side of the Earth, there's another high tide. This happens because the Earth itself is also being pulled toward the moon, but the water on the far side is being left behind. Meanwhile, in areas perpendicular to the line between the Earth and the moon, the water is at its lowest point, creating a low tide. This cycle of high and low tides repeats approximately every 12.5 hours, coinciding with the moon's orbit around the Earth. But that's just scratching the surface. The reality is that the science behind tides is complex and fascinating, involving not just astronomy but also physics and geology. It's a dance of celestial bodies, a ballet choreographed by the laws of nature. So, are you ready to dive into the science behind tides? Because there's a whole lot more to explore. From the role of gravity in shaping tides to the difference between spring tides and neap tides, we're about to embark on a journey that will take us from the familiar shores of our home planet to the farthest reaches of our solar system. Gravity, a force we all know and experience every day. But did you know it plays a crucial role in the formation of tides? Our story begins with gravity, the invisible force that keeps us grounded and makes the apple fall from the tree. But gravity isn't just a one-way street. It's a cosmic dance between all objects in the universe. The greater an object's mass, the stronger its gravitational pull. And this pull isn't just limited to our Earth, it extends to the moon, the sun, and even to the farthest reaches of the cosmos. Now let's bring the moon into the picture. We all know that the moon orbits our planet, but did you know that as the moon whirls around us, its gravitational pull tugs at everything on Earth? Yes, everything, including the vast body of water that covers over 70% of our planet's surface. This tug of war between the Earth and the moon causes the water in our oceans to bulge out in the direction of the moon. In other words, high tide. But wait, there's more. As the Earth rotates, the location of this bulge changes, which is why we experience 2 high tides and 2 low tides each day. Isn't that fascinating? Now, let's not forget about the sun. Although the sun is much farther away than the moon, its gravitational pull also influences the tides because of its immense mass. When the gravitational pulls of the sun and the moon align, we experience more extreme tides, known as spring tides. When they are at right angles, the tides are less extreme, known as neap tides. So as you can see, gravity isn't just about keeping our feet on the ground, it's a cosmic puppeteer, pulling at the strings of our oceans, creating the rhythmic dance of the tides that we observe each day. Gravity therefore is the key player in the tide formation game. Now that we know gravity is the main cause, how does it result in high and low tides? Think of our planet as a large ball, surrounded by an envelope of water, our oceans. Now the moon, our closest celestial neighbor, exerts a gravitational force on the Earth. This force is powerful enough to tug at everything on Earth, but the most noticeable effect can be seen on the water in our oceans. Imagine, if you will, a giant invisible hand reaching out from the moon and pulling the ocean's water towards it. This creates what we call a bulge of water, and this bulge is in fact the high tide. This happens in the areas of the Earth that are directly aligned with the moon. However, there's another side to this story, and to our Earth. On the side of the Earth opposite to the moon, there's another high tide. How so, you might ask? Well, it's because the Earth itself is also being pulled towards the moon, but the water on the far side gets left behind a bit, causing another bulge or high tide. So, we've got 2 high tides at the same time on opposite sides of the Earth. But what about the areas in between these 2 high tides? That's where we experience low tide. The water is being pulled towards the high tides and away from these areas, causing the sea level to drop and expose more of the seashore. This is the low tide. And as the Earth rotates, the positions of high tide and low tide change, making the tides a dynamic and ever-shifting phenomenon. But remember, while the moon plays the leading role in this tidal dance, the sun also has a part to play. Its gravitational pull affects the tides as well, but that's a topic for another time. So, the dance between the Earth and the moon creates the high and low tides we experience. Ever heard of spring tides and neap tides? No, they have nothing to do with the seasons. Let's dive into these interesting phenomena that our moon brings to life. Spring tides and neap tides are the two extreme types of tides that occur on our planet, and they're all about alignment. During a spring tide, which by the way has nothing to do with the season of spring, the sun, moon, and Earth are in a straight line. This happens during a full moon, when the moon is on the opposite side of the Earth from the sun, and during a new moon, when the moon is between the Earth and the sun. The gravitational forces of the sun and moon are combined, resulting in the highest high tides and the lowest low tides. Quite a dramatic change, isn't it? On the other hand, we have neap tides. These occur when the sun, moon, and Earth form a right angle. This happens during the first quarter and the third quarter of the moon's phases. In this scenario, the gravitational pull of the sun partially cancels out the pull of the moon. As a result, the difference between high tide and low tide is at its smallest, and the tides are less extreme. So you see, the moon's phases play a vital role in determining the types of tides we experience. When the moon is full or new, its gravitational pull aligns with the sun's, causing spring tides. But when the moon is at its first or third quarter, the sun and moon's gravitational forces work against each other, leading to neap tides. It's quite a dance, isn't it? The sun, Earth, and moon, all moving in space, influencing the rise and fall of the sea levels. It's a beautiful and constant reminder of our place in the cosmos. And that's how we get the fascinating phenomena of spring and neap tides. Next time you're near the coast, take a moment to observe and appreciate this cosmic choreography. So, let's summarize what we've learned about the cause of tides. Tides are the rise and fall of sea levels, a phenomenon we witness daily. This rhythmic dance of the oceans isn't just a beautiful spectacle of nature, but a significant force acting upon our planet. A force that's governed by the celestial bodies that surround us, namely the moon and the sun. We've learned that gravity, the invisible force that keeps us grounded on Earth, plays a pivotal role in creating tides. The gravitational pull of the moon and the sun on the Earth's oceans causes the water to bulge out in the direction of these celestial bodies, resulting in a high tide. Conversely, on the sides of the Earth where the pull is weakest, we experience low tide. But it's not just a two-step dance. The interplay between the Earth, moon, and sun adds a few more moves into the mix. When the sun, moon, and Earth are aligned, the combined gravitational pull of the sun and moon create what we call spring tides. These tides have nothing to do with the season of spring, but rather, they spring forth with the highest high tides and the lowest low tides. In contrast, when the sun and moon are at right angles to the Earth, their gravitational forces partially cancel each other out. This results in neap tides, which present us with the lowest high tides and the highest low tides. In essence, the ebb and flow of our oceans are a cosmic ballet, choreographed by the gravitational forces of the moon and sun. It's a dance that has been performed for billions of years and will continue for billions more. And there you have it. The intriguing science behind tides explained. Remember, every time you see the tide come in or go out, it's the moon and the sun playing tug of war with our oceans.